Immunoblotting combines the superior resolving power of SDS polyacrylamide gel electrophoresis with a highly sensitive antibody binding assay to detect a specific protein in a mixture of different proteins. Proteins are first separated in an SDS polyacrylamide gel. Then, in the blotting step, the proteins are transferred to a sheet of nitrocellulose membrane. The gel containing the separated proteins is placed on the membrane. Protein transfer is done by electrophoresis. In the electric field generated by a power supply, the proteins coated with negatively charged SDS migrate toward the positive electrode. As the proteins migrate out of the gel, they are captured on the membrane because nitrocellulose binds any protein that contacts it. The proteins stick to the membrane in the same positions they had in the gel. Thus, the membrane is a blot of the gel. The gel is discarded, and an inert protein such as serum albumin is then used to coat the membrane so no other proteins will stick. A primary antibody, chosen to specifically bind only the protein of interest, the red one here, is then added. The albumin coating keeps antibody from sticking directly to the membrane. After a washing step, only the primary antibody that is bound to the red protein remains. Several methods are used to detect the antibody-labeled protein. All use a secondary antibody which binds specifically to the Fc domain of the primary antibody. In one approach, the secondary antibody is linked to an enzyme, so its location can be determined by a chromogenic reaction. The enzyme cleaves a substrate to produce a colored product that precipitates onto the membrane near the antibody. The blue-colored spot on the membrane shows the location of the enzyme-linked antibody and thus the position of the protein of interest.